in this problem, we're extending the drawbridge problem one more step. All right, so we have, again, our hinge. We have our center of gravity, mg. We have the tension T over here. And there's some force F on the hinge at some angle theta. This is our angle alpha. Check my figure again real quick. Yep. Okay. So now, instead of being after T, we're after F. And once again, we've got to figure out how all of this balances. Now, there are a couple of ways we could go at this, but the way we went at it in problem 7, where we figure out T, we have here T sine alpha. And we got here T cosine alpha. So we had T sine alpha and T cosine alpha. T sine alpha causes that positive rotation about the hinge. Mg causes that negative rotation about the hinge. That's a distance x, that's the distance y. And so we're going to just do the torque equation first. T sine alpha onto x plus y minus mgx equals 0, and that gives us T. What's the other thing we know about this? On this hinge, what else can we say? Well, let's ask one simple question. Let's look in x. Is the bridge moving side to side at all? If it's not moving side to side, that means the forces on it going side to side have to balance. And so that would be F cosine theta minus, because F cosine theta is in this direction, right? That's F cosine theta. We also have F sine theta going straight up on the hinge, but F cosine theta going that way, minus T cosine alpha equals 0. So F cosine theta minus T cosine alpha equals 0. In this equation, the only thing we don't know is T. Once we know it, the tension, we go to this equation. The only thing we don't know in this, do we know theta? Let's see. Alpha. We don't know theta yet. Okay. So this is horizontal. Let's look at vertical. What's going on in the vertical direction? F sine theta plus T sine alpha minus mg equals 0. So we've got our torque, we've got our horizontal, and we have our vertical. From the horizontal, we get F cosine theta. We don't know F yet, but we know F cosine theta. From the vertical, we get F sine theta. And what do we know from Pythagorean theorem? F cosine theta squared plus F sine theta squared is F squared. X side squared plus y side squared is hypotenuse squared. Another way to look at this, I'm going to square everything. Squared cosine squared theta plus F squared sine squared theta. Well, this equals, I can factor out the F squared, cosine squared theta plus sine squared theta. Cosine squared theta plus sine squared theta is 1. And so this just equals F squared. And that's how you get this. You got your torque. That's going to give you the tension T. You got your horizontal equation for forces balancing. That's going to give you F cosine theta. You got your vertical equation for forces balancing. That's going to give you F sine theta. Once you have f cosine theta and f sine theta, you square, you add. That gives you the magnitude of f squared, and you're just going to take the square root of that to get f. And that's it for problem 6.